Well, let me tell you a little bit about Lana Pollack before we begin. She was appointed the chair of the U.S. section by President Barack Obama, effective in June 26th of 2010, and she has a very long and very highly respected career in environmental issues and in public interest before her appointment. She served from 1996 to 2008 as president of the Michigan Environmental Council, which is a coalition of 70 environmental organizations working to protect the Great Lakes and Michigan's environment. She was elected 3 times to the Michigan legislature, serving as a state senator from 1983 to 1994. In addition to this, Ms. Pollack was a fellow at the Institute of Politics at Harvard University's Kennedy School of Government. She's taught at the University of Michigan and was an elected trustee of the Ann Arbor Board of Education. She grew up on the shores of Lake Michigan in Ludington, Michigan, and earned a BA in political science from the University of Michigan and an MA from the University of Michigan in 1970. So it's with great pleasure that I turn the webinar over to Lana.
Thank you. Thank you both, and thanks to the Green Chemistry Network. I appreciate this opportunity, and I look forward to working together on issues that I know we share concern. So let me start by giving just a little bit of context here for the IJC, although Lynn has told you many important things. IJC was established as a result of the U.S.-Canada Boundary Waters Treaty of 1909, so we're 103 years old. And the responsibilities that were created under that treaty were for this independent treaty organization, and we're not really a part of either government. We are an independent treaty organization. And our responsibilities stretch, as you can see, I hope, on this slide, all the way across the boundary from the Atlantic to the Pacific, and including north to the Yukon-Alaska boundary. Anywhere there's water that the two countries share, that's where the IJC has responsibilities. And we actually have authority over the flow of waters in many, many of those places. So wherever there's a control structure, we have authority to share out that water. Sometimes, of course, we're upstream in the United States, and sometimes we're downstream, and it's important to have ways of preventing and resolving disputes about the water. Now, the treaty speaks mostly to water quantity, to water flow, to who has the water, who controls the water. But there is one very important clause, and it says, in Article 4, I will read it. It is further agreed that the waters herein defined as boundary waters and waters flowing across the boundary shall not be polluted on either side to the injury of health or property on the other. That gives us an interest in water quality, in pollution, and that's where we move from there. I'll just say one more thing. That there are, as I believe has been mentioned, 3 U.S. commissioners appointed by the President and 3 Canadian commissioners appointed by their government. And each of us takes an oath of office to uphold the respective Constitution of our country, but we take a second oath of office as well, and that is to administer the treaty and to do our work here without regard to our nationality, without bias. And so our interest is in the waters that we share, as opposed to the waters that might, for the moment, be on one side of the border or the other. Now here we see a slide of the Great Lakes Basin. About half of our resources, attention, focus, are right here in the basin, and that's, of course, what we're going to be talking about today. I want to draw attention to this slide, because if you look closely at it, it might not look so impressive, but it really is. Because you see, you cannot tell where the political, the national boundary is, and neither can the waters. What we have here is a rather new achievement, which is to say the data has been harmonized, and you can see the various sub-watersheds in the Great Lakes Basin on those dark green lines. And previously, before we worked to harmonize these data, and that happened with a number of organizations, Environment Canada and Ag Canada and USGS and the EPA, of course, and several agencies on both sides collaborating and contributing their data. Before that, the rivers didn't all line up, and the elevations didn't all line up. And so if you're doing research on the flow of water, which is, of course, absolutely critical to understand the pollution and the water quality, you couldn't do it across the boundaries very well. That is a major effort that we've undertaken in the last couple of years, and it's been well recognized by people in the field of data harmonization and data management as really, frankly, quite a spectacular achievement. And we're doing that right across the boundary. Now a little history. This will look familiar even to those of you who are much too young to remember this. You know, the interesting part about this picture, I think, that it's 1969. It's the Cuyahoga River on fire, just from the sludge and oil that had been allowed to seep into it as rather an open sewer. The interesting thing here is that this picture could well have been taken, and there were similar pictures taken in 1959 and earlier. In other words, it wasn't as if one day the river burst into fire and people said, oh, the river has become polluted. No, the pollution was there and accumulated over many years. And so one has to ask the question, why in 1969 did this become such a cause célèbre, and why was this picture on the cover of Life magazine, and why did it generate so much interest and insistence on change in both countries? Well, the answer is because the public was involved, the public was motivated, and it was a time of great social change. And I will make that point more than once. That is to say, the pollution can be there in any amount, but if the public is not there insisting on change, then the pollution will stay or increase or get worse. Everything comes back to at what level the public is willing to engage with their governments. So what happened at the point of the public engagement is that the IJC was asked by both Canada and the United States to study, in particular, Lake Erie, Lake Ontario, and the international section of the St. Lawrence River. And they said, you know, give us advice. What should we do? The IJC took that to heart, did do the study, reported to the governments, and in 1972, the United States and Canada signed the Great Lakes Water Quality Agreement. This is an interesting picture because anybody who knows even a little history of this period knows that Nixon and Trudeau really couldn't stand each other. But there were public pressures that insisted that this move forward, and it did. In the very bottom right-hand corner of your screen, if you look closely, I think you can see a little insert that says something is treason. Oh, capitalism is treason, I think. Or continentalism is treason. At any rate, when the day that this was signed, there were a great protests because Nixon was in Ottawa, and he wasn't the most popular fellow. But we do recall that Nixon was the president who signed many of the pillars of the United States environmental law, the whole context, the architecture, really, that was developed at that time. And I think this is what's important to recognize, too, that agreement, which has been subsequently redrafted, as you can see on this screen, that agreement and the subsequent agreements, they are binding on the governments, but they are not enforceable. That is to say, the laws of each country are what drives the enforceable regulatory controls. But the fact of the agreement and the goals and the objectives of the agreement drove a large number of changes in law on both sides of the country. In 1972, of course, we were looking primarily at point source pollution, and one of the things that happened following that is that there was a number of laws that were passed, but equally important. There was a great deal of money that was invested in both countries, and they invested it in wastewater treatment plants and other controls for the point source pollution. I'll give you a little preview, and it's not a secret that the primary issues that we face today are the non-point source solutions, and we still have a great deal of work to do. But we're going to take a look momentarily at some slides that shows just what the results of those early agreements and legislation that followed were. In 1983, well, let me go to 1978, as you see on your screen. They approached it as a more of an ecosystem approach, and committed to the integrity of the chemical, physical, and biological health of the Great Lakes, which is, of course, the principle on which we operate today. In 1983, they added the phosphorus load reduction and set targets. I repeat that because we're going to come back to the role of targets for phosphorus and other contaminants as we work our way through this report. And then the remedial action plans that were important to the historically contaminated areas of concern were added in '87. And in '87 too, I pause to say this, that many of the roles and responsibilities that had been assigned previously to the IJC were at that point assigned back to the government, that is to say Environment Canada and the EPA. Note, of course, that in 1972, both of those agencies, both of those federal agencies, were either non-existent or in their infancy. So a lot of the responsibilities that were subsequently assumed by those agencies were in the early years assumed by the IJC. I want to move forward now to a new agreement. In 2012, in September of this year, a new agreement was signed. We'll talk about some of the elements in that agreement. You see there not the President's signing, but you do see the head of EPA, Lisa Jackson, and Minister of the Environment in Canada, Minister Peter Kent, signing the agreement. And the agreement that is new adds a number of elements that the IJC is pleased to see. It has a lot of potential. We think it's well organized. There's more emphasis on human health. There's more emphasis on the precautionary approach. They don't say precautionary principle, but they do say precautionary approach. There are there's new focus on areas that were not so well known years earlier, the invasive species and of course climate change, groundwater. A number of important additions. I think the most important change in this iteration of the agreement is the greater opportunity for public participation. There's some new restructuring there that invites public participation. How that is used is yet to be seen, but upon that, I think rests the success or failure of this next chapter of the Great Lakes Water Quality Agreement. Let me just say one disappointment in the agreement is that it doesn't have numeric targets. It doesn't have the standards. It doesn't have it doesn't have the number, the goals, the target by which the governments will judge themselves and by which the public and the IJC will make judgments. It does say that the phosphorus targets will remain until modified at the same as what they were in the previous agreement. That's the only numerical target that's in the agreement. And it does commit the governments to setting targets for all of the 9 annexes within 5 years. And that is an opportunity, I think, and an invitation for the public to invest themselves in the green chemistry community, to invest itself as those targets are being discussed and determined in the next 5 years. There is one of the 9 annexes. There's one that I would pause here because it's on target for our concerns here today. There is an annex, a new annex on chemicals of mutual concern. Now, those chemicals are not yet named. They're meant to be distinguished from the historic legacy contaminants with which we've been working for several years now, since 1972. But the recognition that with pharmaceuticals and any number of other chemicals that were not really a feature of concern previously, but are known now to be of concern, they will get attention. How will they be named? They will be named by the governments. There has to be agreement on both sides of the border. The Great Lakes Executive Committee, which for those of you who are familiar with the old agreement is taking the place of the Binational Executive Committee. That is to say, a committee of the various agencies at governments on both sides of the border and all levels. They have the authority to recommend to the governments what the chemicals of mutual concern should be, how they should be nominated, and how they should be dealt with. That, too, to me, is an invitation for further public engagement, and I would encourage people interested and knowledgeable to participate in that process. Now, turning to our report, we have, as Lynn mentioned, under the agreement, been charged, the IJC has been charged with binational reports on the state of the lakes, on progress towards the objectives, meeting the objectives of the agreement. And we are about to publish the 16th biannual report. I will go into that momentarily. What you're looking here is that is a draft design for the cover, which has been rejected by all who have seen it, and certainly including me. So anyway, you'll see our 16th biannual report will be published. It will be online. That will happen in January, and it will have a slightly or substantially different cover. Let me first go through what's in this report. What's in this report is a look back at the last 25 years. The report is designed to look at trends in the health of the lakes over the last 25 years, and to do so by looking at the chemical, physical, and biological indicators. We used only indicators that we had either 25 years or an appropriate length of time, so we could show some trends rather than just taking snapshots in time. And we tried to, we didn't try, we used the best science. It's being reviewed and commented now by both EPA and Environment Canada, but it is an independent report by the IJC. It's also had peer review from a host of other scientists. What we find in what we try to do is answer, are the Great Lakes getting healthier? That's what people ask. And yet we needed to base that on science. And unfortunately, that's not simple answer. So what we had is 7 chapters on chemical integrity of the lakes, and let me highlight just a little bit of it now. This is a good news story, and I pause here to say that because I think those of us who are environmental advocates don't either take credit or really celebrate success, because we recognize what's left to be done. We recognize that what we've done and what we've achieved is not enough. But on the other hand, if we don't celebrate success that comes as a result of advocacy and better laws and greater investments, then we will only discourage those who we are trying to convince to continue to advance better legislation and more results. So I like this because it's a pretty clear downward slope. Several PCBs in the blue line shown. Again, we didn't see the elimination, and we would like to see the virtual elimination, but we did see substantial reductions between 1987 and 2009, and that is important, and that should be recognized so that we can show success as we seek support for further success. We see here PCBs in lake trout. Excuse me, I neglected to read the what you no doubt read. It's a level in herring gull lakes, and so what we did in this report is take, of course, several different measures of this. And the herring gull eggs and eagle eggs, eagle shells. There's a number of different ways of measuring this. Herring gull eggs is one of them. PCBs in Great Lakes trout. I believe this one is the entire fish, including the bones. So there are ways, of course, of measuring only the parts that people eat, but this does give you a sense of the different lakes, where the PCBs were in as far back as the early 70s and where they are now. And you see, again, some bouncing around, especially in Lake Michigan. You see that the job is not done. You see that the data is not totally complete in this data either. But you see the results of legislation that's set about to protect the public by frankly the banning in this case of those chemicals. Here we have looking down in the vertical, you see PCBs and then mercury and then PBDEs. And across, you have the 5 lakes represented. So you can see that PCBs in Lake Superior were never as great, and never as high in concentrations as they were in some of the other lakes. But you do see a slight improvement. You certainly see a substantial improvement in Lake Ontario, Erie, Michigan, and Huron. And in Mercury, it's a different story because you saw substantial improvements early on, and then a leveling off, or even a rise again remains a problem, and remains to be addressed. And the PBDEs, the fire retardants, of course, they weren't invented when these, or at least they weren't well used in 1970s, 80s, and into the mid-80s. And then as they become used, you see how they start they're showing up in the water column. And you also see when there was a voluntary elimination of 2 out of the 3 main classes of PBDEs, you see a reduction. All this points out is that when the chemicals are manufactured, incorporated into products, used in products, dispersed and transported in products, they show up in the environment. Here we see a percent reduction in legacy contaminants in sediment. And again, the job is not done, but I think it's terrific to see that in Lake Huron, there's been a 93% reduction in DDT, a 73% reduction in mercury in Lake Ontario. And this is from the percent of reduction is taken from the highest point of that contaminant, which might have been in the 70s, or if the highest point was in the 80s, it was measured from the highest point to recently. And this work is done by Environment Canada. And I mention here that we had a great deal of support and assistance in the science that was being presented. A lot of it was done by the federal agencies in both countries. Although the recommendations and the policy recommendations are all the IJCs, the source of the data is mostly governmental, for which we are appreciative. Here we're looking at sediments concentrations in sediments by depth. And you unfortunately see in this perfluoroalkyl substances, PFASs, and the BDEs again, you see increases. You see unfortunate increases. And you see we have work to be done. Because it's not just, these things, they don't stop in the sediments, of course. They end up in the breast milk. They end up in the food chain. Phosphorus is a particular challenge. Lake Erie was pronounced dead. There was a lack of oxygen. It was primarily, a mess of algal blooms in the 70s. Got much better in the 80s and because measures were taken and improvements were made. We were looking then at that time particulate phosphorus loads. There was some slight reductions. There was a great deal of reduction from improvements that were made in wastewater treatment plants. Again, big investments of large sums of money, both by Canada and the United States in those decades. Those are plants that are in facilities that are aging now without quite the same investments to reinvent them. But the main problem today, we believe, is the dissolved reactive phosphorus loads, which up in the upper right you can see it went down and then went up. And the bioavailability that you can see in the bottom slide also increasing in recent years. Now, what you see there also varies by year because there's substantial impacts on runoff depending on the precipitation patterns. You have very heavy, fast, thick rainstorms. You're going to get a big wash-off. 2011 was a terrible year for algal blooms, and we'll look at that momentarily. But 2012 was much better. And why? It wasn't anything anybody did better. It's just it was a drought year. We have to get beyond just depending on the weather and hoping that the weather will save us, because drought in itself is not an answer to many things. But we have to engage the agriculture community in much, much better practices, and I would say beyond that in increasing the number of participants. There's a number of problems on both sides of the border, and there are a number of protections that are given to the agriculture industry that are not given to other industries. That is to say, protections from environmental regulations, but not protections for the environment. These are policy challenges, they are political challenges, and they are economic challenges, because the agricultural industry is, of course, extraordinarily important, but so too our waters. Excuse me. Yes. A picture that if it were just a child's finger painting would be beautiful, or a Jackson Pollack painting would be beautiful. But this is, unfortunately, the western basin of Lake Erie, and what you're looking at is 2011, the worst bloom of harmful algae in recorded history. We have problems. Now, I've mentioned the runoff that is a substantial contributor, but we also have climate issues that complicate it, and we have, in addition, we have the little quagga mussels or zebra mussels that you see between the fingers of in the center upper little insert there. So the chemistry of the lakes has been changed by these little animals. Not all invasive species, as you can see below, are as big and as charismatic as the Asian carp. Sometimes it's the smallest animals that do the gravest harm and get the least attention from the public or the government. In the left, I'd like to say that you've got a bar graph. And if you look at the blue in the bar graph, that's the decades. The number represents the number of invasive species that were introduced in those decades. And you can see that we're pleased that in the last decade, the most recent decade, 2000 to 2009, there's been a reduction, and that is because there's been a better ballast water treatment, stronger ballast water practices that have been put in place. Whether they're strong enough or not is under discussion, but we do see some improvement in that. And I point to this slide as an example of one of the biological indicators that we incorporated into our 16th biennial. As I said, we looked at the chemical indicators and had 7 chapters on that. We looked at 5 biological indicators on the health of the lakes, and the invasive species certainly here being featured. And we also looked at two indicators of physical integrity. And here you're looking at a substantial change in the amount and the period of time that the lakes have ice on them in the winter. And you see that Lake Superior, you can see the downward slope on all of these. And they all, frankly, have at least a reduction of nearly 50%, and as high a reduction as 80%. And it goes back actually to the 70s that you could start measuring the loss of ice. Not every year a loss from the preceding year, but over the decades, definitely a loss. Why is this important? Well, it's important because it impacts on the evaporation. Greatest evaporation in the lakes is in the winter, and especially so when you have the contrast between the warm water and the cold air. And evaporation and precipitation are the 2 primary controlling factors of the lake levels. And lake levels now, I can say as an IJC commissioner, is the issue which the public is most exercised about. I mean, we have thousands of communications from people who want us to do something about the low lake levels. Frankly, there's not much that we can do. And although climate change is, science is not so certain about the precipitation patterns that we can anticipate in future years, it does indicate that we can expect warmer winters, less ice, more evaporation. So if the lakes were to rebound to their historic normals, and there are always fluctuations, but if they were to rebound to their historic levels and ranges, it would take more precipitation to get there because there's going to be more evaporation, which will be forcing the lakes lower. That's why one of the major recommendations of this report is about, it speaks to adaptive management. Even if the countries and the world were to take actions now to reduce the carbon gases flowing into the atmosphere, we've got decades, really a century, where we're looking at the consequences of a very, very carbon-loaded atmosphere. And we're going to have to adapt to that. The waters are going to feel it, and we're going to feel the water changes. And adaptive management is a key. In summary, we looked at, in this report, 7 indicators of chemical integrity, mostly favorable or stable results, but not consistent. There's a leveling off or even a reversal in toxic contaminations or nutrient loading in the past decade. That is to say, the great success that I was saying, come on, celebrate, celebrate, those successes came decades ago. We need new success, and we need new investments and new policies. The physical integrity, the 2 indicators, again, reduced ice cover and rising surface water temperatures, that will create challenges for everybody who uses the lakes, and it will have, I assume, some impacts on the chemistry of the lakes as well. Biological integrity, we measured 5 indicators with mixed results. The good news is that with some stronger ballast water standards, we see some new protections on the invasive species. But we are living with a number of invasive species and need to both protect against new ones and learn to manage with the old ones. We had 2 performance indicators in there. That is to say, we looked at the progress on the AOCs, on cleaning up the historically contaminated sites. Early on in this period, that is to say, in the 80s, Canada was way ahead of the United States in their investments and in their progress on the AOC cleanups. More recently, with the Great Lakes Resource Initiative, the monies that have been put in the United States, most of the activity is on this side of the border. We've got about 25% of the individual impairments, beneficial use impairments, removed, but we have a lot of work to do. So progress there is clearly linked to focus, effort, and expenditures. Without the focus, without the effort, and without the expenditures, none of these things do very well. Hang on, I want to advance this. And it's stuck. Okay. So what are some of our recommendations? And this is, I think, this is a request for involvement. Governments should invest in educating consumers and to providing incentives that encourage them to produce more environmentally friendly products. But how do we get the governments to do that? Well, that means to say that the public and the groups such as the green chemistry community need to be a key part of educating the governments as well as the public. So we want to see direct involvement by the public, but to do that we need education, we need outreach. We expect the government to do it, but we know that that too starts with the most interested and the most informed individuals. We are frustrated when we see the government's cutting back on monitoring and on reporting, and we see it. We're seeing it today still, where there has been a loss of investment in many of the monitoring stations. That happened early on when they declared victory on phosphorus in the tributaries to Lake Erie, but it was a short-lived victory, and so we really have to get better monitoring on a number of things. It's a small investment for a large return. Governments should develop and implement best management practices to reduce dissolved reactive phosphorus runoff from agricultural lands. Yeah, they should develop them, but they have to see them implemented, and somehow we have to do better at tying the costs and the consequences together. I think we failed, and I know we failed. Just look at that picture of Lake Erie from 2011. We have a long way to go there. And then the states of Ohio, Michigan, and Wisconsin should work with the U.S. EPA to complete the phosphorus TMDLs, the total, the daily loads. Total maximum, excuse me. I blanked on it. Total maximum daily loads for the respective water bodies of western Lake Erie and Saginaw Bay and Green Bay. These are the three most impacted areas, but not the only impacted areas. And Canada does not have TMDLs, which when implemented can be a very effective control program. And so the IJC is recommending that Canada implement programs comparable to the TMDL programs at either the federal or the provincial level. The provincial level in Canada playing an extremely important role in environmental protection. The governments also need to select a limited number of core chemicals, chemical, biological, and physical indicators. People want to know, are the lakes getting healthier? They want to know whether things are getting better or worse. And sometimes the perfect is the enemy of the good, and every scientist has something to contribute. But among all the different science studies, we need to narrow it down and say these limited dozen or 2 dozen indicators are the ones we're going to track over time, and we're going to invest in the monitoring, and we're going to be consistent about that, and so that we can tell a story that people can understand, that is science-based and comprehensive, but yet direct and focused enough to motivate our governments to take the actions that they should be taking. We have seen significant achievements since 1987, really since 1972, but the evidence cries out for a renewed commitment to protect and restore the Great Lakes because we're not there yet. And with that, I hope that there are some comments and questions for the minutes that we have left. This report, which is, as I said, all but complete, will be posted on the IJC website. That's ijc.org, O-R-G, in January. And we invite you to visit that. We invite you to be in touch with us. Part of our responsibilities are, a major part of our responsibilities play the role of listening to the public and transmitting the wisdom of the public to the government. Thank you. Lana, if you have some questions.
Thank you so much, Lana. That was really interesting, and we really appreciate your presentation. I already have 3 questions, and we don't have much time, so I'm going to read them to you quickly, and let's see if we can squeeze them all in. The first question is, did the dredging of the Sinclair River have an impact on the lake levels of Huron and Michigan?
Do you want to read all the questions, or you want me to answer that right now?
Yeah, just go ahead and answer them.
Okay, the answer is yes, it definitely did. There's some scientific back and forth exactly how much, Probably the best. You couldn't say that there's much more than, I think, 22 inches of. I'm looking at John Nevin here.
From the dredging, 15, 16 inches from the dredging itself, and then another 3 to 5 inches from subsequent erosion.
So if you put it all together, you have less, maybe 20. I want to be generous because there are people who say it's all caused by it, but I want to put this in context. Remember that if you look at the high water levels, which happened in the mid-'80s, and to where we are today, which is close to the record lows, there's been almost a 2-meter, almost a 6-foot drop in water. So some of that, perhaps 20 inches, is related to the dredging caused by the dredging and the scouring that could have been prompted by the dredging. We have larger issues at hand, and it's called climate change, and it's called evaporation, and it's called drought. But that is not to say that the dredging was not a contributor, because it was. The last dredging, by the way, the last significant dredging was in 1962, after which we think there was some inches of scouring that some people attribute and connect to the dredging, but that's not certain. Anyway, so let's take the next question.
So the next question is, what do you think needs to be done to speed up progress on the AOCs? And a related question is, why must it take 3 to 5 years for Canada and the United States to agree on a list of chemicals of mutual concern? Can't the IJC recommend a list of these chemicals now based on the IJC's existing information?
The IJC can. We did some work on CEC's chemicals of emerging concern. I think, frankly, are not right now prepared. We would have to and could invest our resources and prepare to do that. And I would take that as a suggestion that we might make a contribution. Why does it take governments as long to do anything? That's a longer conversation than we're going to have. But to be fair to governments, they need to touch base with a lot of people, and they have to do so in ways that are both transparent and comprehensive. But if you hear my frustration too, I think that I would have liked to have seen some chemicals of mutual concern already listed, and I would have liked to have seen some numeric targets in this agreement. But there is an opportunity for all of us to be engaged, and I think the governments are inclined to listen, especially if we are effective in the way we do it. And the IJC wants to be a partner in that with you. Did I miss a question? Wait.
Yeah, one was about what can be done to move the work on the AOCs forward
faster. Well, I think that I think on the U.S. side right now, after years of slumbering, they are investing. Part of it is money. Part of it is targeting the money well. There's a lot of competition, though, and reasonably so, for the GLRI money. People would not be happy if all of the money were spent on the AOCs, because you wouldn't be spending any money on any number of other problems that we've discussed and highlighted today, too. So that the historic legacy contaminants and the areas of concern are really important. But there's so many other forces that are operating on the Great Lakes now that, let me just say this too. Like, it doesn't take long to contaminate a place. It takes a long time to clean it up.
Well, just an example, Calumet Harbor in Indiana, it's taken a very long time to address the kind of dredging needs to remove the contaminated sediment because there was no place to put the sediment. There's no disposal facility. So finally, there is now a facility for that sediment, and just a couple of weeks ago, that dredging project got underway. So there are other, sometimes money is the problem. Sometimes it's, there's other physical barriers that also stand in the way.
Yes, and that's an issue with very familiar because that's in my backyard, and I'd just like to point out that that dredging has taken over 20 years, 20-plus years since they first started talking about it, and even though they have found a place where they are putting the dredging, it's not a place that has made anybody in the community very happy, so it's an ongoing issue.
Well, let me just say this that I say over and over when I speak. Political will. I mean, we need the science, and we need to base our work and our remediation and our prevention on science. But really, what's lacking usually is political will, and that's why you hear me over and over, and the IJC in general invite the public to become active with us in these matters.